Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Weakening Sun, Source Radiation Measurements Are Not All Solar Radiation. Now, SOURCE is a NASA satellite operating at an orbital altitude of 645 kilometers. According to NASA, the satellite is designed to measure solar radiation. But if there are sources of radiation other than the Sun between the Earth and the Sun, can it be assumed that source radiation measurements come directly from the Sun? The answer is no. It cannot be assumed that the measured radiation is coming exclusively from the Sun, and therefore we cannot infer from these measurements the state that the Sun is in. Now here we see the Sun being eclipsed by an object which emits X-rays. We know it emits X-rays because this is a soft X-ray image from the Yoko satellites from 2001. So this large object is seen eclipsing the Sun, and therefore this is its night side, and we can definitely see it's not completely black. We see lots of brown spots here, and this shows us that it's emitting X-rays. So we have an object eclipsing the Sun that is capable of emitting X-rays. This is not the only object. We can clearly see a perfectly circular outline here, indicating that there is another object. We also see part of the Sun's corona in front of the object. So this object is in the Sun's corona. And we see another one here. This one seems to be smaller than this one. So therefore we have three objects close to the Sun, or at least two of them we know are very close to the Sun because some of the Sun's corona is actually in front of these objects. So we have therefore three objects that emit X-rays in these images. And of course, they are not natural objects to the solar system. So we have therefore several sources of X-rays, not just the Sun, in the inner solar system. Now, since these objects are capable of emitting X-rays, it is very likely that they are able to emit radiation at other wavelengths. Now, we can actually see contours and features of this object's surface by looking at this image, which shows that it's definitely emitting X-rays. So this is also a short exposure X-ray image. The exposure length is about 1 second. And the fact that the emitted X-rays allow the imaging of the object's contour shows that these are emitted, not scattered X-rays. And we can see curved contours close to the object's equator, and this indicates its curvature. These are curved, and these also indicate that the area is slightly raised over the rest of the surface. You can see an extra layer here, and this is therefore likely to be like I said, a different layer of material covering the equatorial region of this object's surface. Now, some people will of course say that this is the Moon, but it is impossible for this to be the Moon because the Moon does not emit X-rays. The Moon scatters a few solar X-rays, and the number of X-ray or solar X-rays scattered by the Moon are so few that this is a 30-minute exposure of the Moon in X-rays. And you can see on its night side there are very, very few scattered X-rays. And so this is 30 minutes, this is a 1 second. So there are so few X-rays scattered by the Moon that it's less than what is coming off the surface of this object, the night side. We'd compare night side with night side on both the Moon and this object, that this is what is coming out in 1 second for this object, and this is what's being scattered by the Moon in 30 minutes. In other words, 1,899 seconds. So this shows that this object is clearly not the moon. Also, the number of X-ray photons is such that we cannot even see any contours, any details about the moon's surface, and that is because these are not emitted X-rays, these are scattered X-rays. That means they are reflected by the moon's surface at all sorts of angles, which does not allow imaging of the surface. Now, so if these objects, so we clearly have objects that are emitting X-rays, we therefore have additional sources of X-rays in the inner solar system, and if these objects emit X-rays, it's likely that they will emit other wavelengths of light. And here we have an SDO image. And this is a composite SDO image, and it shows an object in the sun's corona. And because we can see this object, we know that it is emitting light in the wavelengths of this image, and obviously it's ultraviolet. Most of the SDO images are in ultraviolet, and this is a composite ultraviolet image. And we can see this object is clearly a spherical object. We can even see that it has stripes that are curved and clearly follow the contours, the curvature of a spherical object. So we clearly have a spherical object in the sun's corona that is emitting ultraviolet radiation. And this shows that these types of objects, and I call them Planet X objects, call them stellar cores, that these objects, which are basically part of a system of dead stars that have invaded the solar system, emit radiation just like the sun emits radiation. And in fact, they connect to the sun, they draw energy from the sun, and these objects are responsible for the sun having become weak and losing a lot of its ability to emit light at the same intensity it did before. And so we cannot assume that all the radiation detected by the source satellite is coming from the sun. We can therefore also not assume that whatever radiation measured by the source satellite tells us about the state that the sun is in. Basically, if the radiation that is detected is normal or above what it was before, we could say, oh, the sun is emitting all this radiation, therefore the sun is still strong. But the fact is that the sun is much weaker and getting increasingly weaker, and this is obvious from the SDO images, which best show the sun's corona, and these are the 211 angstrom images, and we can see that the sun's corona is getting smaller and smaller. It's basically disappearing. We now have permanent coronal holes at the north and south poles of the sun, and we basically have a permanent coronal hole now that has developed in the sun's equatorial region. And this shows that the plasma density within the sun's corona has decreased more and more to the point that there's hardly any corona left. We do not see it on the sides of the sun usually because we're seeing the corona from the side, and it will seem to have a higher density. But the moment the sun turns to face the spacecraft, then we can see how thin it has become. Now, these are images from several years back. This is the sun in 2018. This is the sun in 2017. This is the sun in 2015. And this is the sun in 2011. 2011, the sun was only, this is from only just a year away from the last solar minimum. At the moment, the sun is about a year away from the next solar minimum. So if we compare the two, and even if we compare 2011, 2017, we can clearly see how much the sun has weakened. We also had that by 2015, a permanent coronal hole had opened up at the sun's southern equator, and this was quite close to solar maximum. This shows that the sun has been weakening independent of the solar cycle. Now, in addition, there is evidence that from a patent from 1977 that the ionosphere and the Earth's magnetosphere are being manipulated through the injection of cold plasma, such as ionized hydrogen, or through barium clouds, causing an increase in electron density and leading to the creation of artificial aurora at the magnetic poles. So, and in the same patent, it's also mentioned that high altitude nuclear explosions were being done. And this indicates that radiation detected by the source satellite can be artificially produced. This also means that neutron or alpha particle detection cannot be assumed to all be coming from the sun or even from interplanetary space, as it is possible it arises as a result of a nuclear explosion having taken place within the Earth's magnetosphere. And you may look at Article 222 entitled Artificially Manipulating Ionosphere and Creating Space Weather Through Chemtrails. And I have an article entitled Stellar Cores and the Dying Sun, that's Article 193, that specifically talks about how the sun has weakened and how the stellar cores lead to it weakening. Now, this is a graph. It comes from a paper by Livingston and Penn, and they studied the sun's magnetic field associated with sunspots, and they discovered that it had dropped independent of the solar cycle during solar cycle 23. So between 1995 and 2009, the sun's magnetic field associated with sunspots dropped at about a rate of 50 Gauss per year. So that was between 1996 and 2009. So independent of the solar cycle, the sun was already weakening during the last solar cycle 23. So in conclusion, it cannot be assumed that a radiation detected by the source satellite is coming exclusively from the sun, and it cannot therefore be inferred from that data that there is nothing wrong with the sun. Measurements of the magnetic field associated to sunspots had already shown that the sun was weakening independent of the solar cycle by 2009. In addition, SDO images over the years clearly show that the sun is increasingly weaker and darker, indicating that it is emitting radiation at a lower intensity. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.